of 5x. Does that look right to you?
Yes.
All right. First thing for me here, if I were showing you how to do this, is I would change it to the natural log of u, where u is tangent of 5x. Have you
Okay.
seen that before? Is that okay?
I have not seen that before.
So I like to kind of separate these out, especially first time you're seeing it. So the derivative of u, p prime of u, is 1 over u times u prime. It's the same as maybe what you've seen in the class. It's 1 over the inside function times the derivative of the inside function, but it just kind of separates it out here because the derivative of tangent is secant squared 5x, but this also has an inside function. The derivative of 5x is 5, so the derivative is 5 secant squared 5x, like that. So now you're just grabbing the stuff that you come off to the side. You're like, okay, there's u prime, and you just put those back in. It's just an alternative way to sort of do these. So it's 1 over tangent of 5x. U prime is 5 secant squared 5x, like that. And then, depending on your instructor, maybe you have to simplify, maybe you can, maybe you can't. I didn't
It
even look
doesn't
here.
matter with me. So,
Okay. So I'd be okay with this. And then it's, p prime of x as your final answer, like that.
okay, that makes
Most
sense.
common thing would be to forget the derivative of the inside function. Looks like maybe you didn't write derivative notation also. They're big
Yeah,
on notation.
yeah, yeah. Okay. I got it. I just was doing like extra work that I didn't have to do.
All right. So number 11, is that the next one you'd like us to look at?
Yes.
All right. Now this is not formatted well. It should say cotangent parentheses 3x, like that, to make it really clear that it's the inside function is 3x. Um, Again, like all those derivative rules, it's really like this. It's really the cotangent of u, and u is 3x. Like you
Yeah.
don't know the derivative of cotangent 3x, even though you might think you do. You only know of like this thing called u. U represents 3x. The derivative is minus cosecant squared of u times u prime.
Yeah.
And so what is u prime?
Just
Well,
three.
it's just 3, and then you're just feeding those back into the original. So um, the answer is minus cosecant squared 3x times 3. And then if you want to simplify, you can. I was actually just working with a student whose teacher completely emphasizes the simplifying. And so he's
Yeah.
having a lot of trouble because, it's like a whole nother problem if you have to simplify.
Yeah. Okay.
Looks like you use some variation of like product rule or something on that.
Yeah.
All right. And then number 6, is that the
Yes.
next one? Okay. All right. So we got,
And
okay.
I think for this one, the like sign to the fifth power is what threw me off.
Yeah, you probably actually want to rewrite it like this, where it's to the power of 5,
Okay.
and that will help with the derivative. So the derivative is actually a power rule followed by a chain rule followed by another chain rule.
Yeah.
And so this is your like f and your g.
Okay.
And I almost want to see that kind of off to the side if I'm grading you. I want to see your derivative of this off to the side. Could
Okay.
you try that derivative one more time?
Yeah. Okay. So I think it's 20 sine 4x to the fourth power.
Like, let me show it out kind of in the right. You got a lot of it there. It's 5 times sine. 4x to the power of 4. Derivative of sine, though, is cosine of 4x
Ooh.
and then times 4.
Okay, so 5 sine of 4x to the fourth power. Cosine of 4x. Okay,
All right, now
so
give g prime a try, please.
okay. So it's 6x squared times e to the 2x third power.
Like that, perfect. Okay, the rest of it is just putting it back in using the formula. So if you don't have the formula down, that could be an issue, but it's the bottom. Probably good to put them in parentheses times the derivative of the top, which is this mess you were asking about. So if you simplify, it's 20 cosine 4x sine to the power of 4x, like you want to do that for the AP, minus the top sine 5 4x times root of the bottom, all over the bottom squared.
Okay. And I can just leave it like that, right?
For your teacher, I guess, this other student I mentioned, he would have to work on this. That it takes
Yeah.
almost as long, if not longer.
Yeah, okay. That makes sense.
All right. Any questions on that?
Not on that one, no.
Could I have you try one more of I'd like just kind of as an aside question here, just
Yeah.
to see if you've got it. Let's say it was something like this. Y equals 4 tangent cubed 6x. Could you try taking the derivative of this? And I would recommend rewriting it.
With the u?
No. Well,
Yeah.
maybe, but this is what I was referring to when I say rewrite it like
Oh,
that.
the 3. Okay.
So you know that it's a power rule, and then you can decide if you want to use any further chain rule stuff.
Alright. Okay. So the 4 just disappears, right? Because it's a constant.
It's a constant times a function, so it stays with it.
Oh, okay.
The three multiplies the 4.
Oh, so it's 12. Okay, so 12 secant squared 6x squared
So
times.
you gotta keep the inside function. 12 tangent 6x squared. Keep like it's power rule.
Okay.
Then you take the derivative of the inside function.
And then it's secant squared 6. Oh, wait, 6 secant squared 6x.
And a little more, what's the derivative of 6x?
6.
Yeah.
Okay.
Do
And
you
do
want
I
me to
have
give
to,
you,
do I have
do
to
you want me to give you
multiply?
one more like this, or do you feel like you've got
Maybe just one more, yeah.
okay. I would again recommend rewriting this.
Okay. I got negative 36 cosecant e to the 2x power to the fourth power, and then cosecant e to the 2x cotangent e to the 2x times 2 times e to the 2x power.
Okay. The only thing I think you meant the 4 becomes a 3. I don't know what you said there, but it should be
Oh,
3.
yeah.
And then you said a negative. Where does that's from the that's okay, now I
This,
get where you come that's from. Okay. Yeah. So that is good. I think you got it down.
okay, perfect.
All right. So we can look at your review next. Um, and I'm only asking because I just to see, have you tried any of the problems yet? Not there's no judgment here if you haven't. Just have you tried any of these yet?
I have not. We actually just got the assignment today. So,
All right.
so it's just R1 through R9, and we don't have to do R7.
When they have like multiple parts, that's a lot.
Yeah.
Um,
But we don't have to. Also, wait, hold on. Before we do this,
I mean, I should. There's ones I think that would be useful to do. Like R1 could be okay. I mean, R2C is a good one. Just maybe there's some you feel like are worth more
yeah,
effort
like
than
there's some
another.
of them that are just like super like easy that I could definitely do on my own. Um, but like R5 and R6C mainly, C and D for R6, and then actually I think that's like the only ones that we really need to go over.
Does your
Maybe R9.
does your instructor typically emphasize graphing?
Not really, no.
Okay. Do you want me to graph these?
No, we don't have to do
Okay.
any of that.
I mean, I'm happy to. I'm only asking because I don't like, so it's up to you. So for the part double I to determine whether the function is continuous, this is actually something you did, maybe a month ago in the course. Continuity means that it just has to approach and be the same value. It's different than differentiable, which I guess is the next one. So you just have to prove that the number from the left, uh, you're basically evaluating it from the left and from the right. Um,
Yeah.
so it's that the limit as x approaches one from the left equals the limit as x approaches one from the right equals f of one.
Yeah.
Basically, at this break point here, you're going to put one in for x in both and see if it's the same. One
That's
squared
cool.
plus one. Does that
Okay.
equal minus one squared plus four times one minus one?
Okay. Um. So 2 equals. They do not equal each other.
They do not. So it is not continuous.
Okay.
Wait, I disagree. The one on the right here is negative one plus four minus one, which is two. The one on the left is
Oh, wait, yeah,
two.
they are both 2. Okay, yeah, yeah. That's my. Yeah. Okay. So whenever we're doing whenever like we did the piecewise functions in class, we like had to set them equal to each other and then like plug them in, like plug one in, and like
You're thinking of a problem where they give you a piecewise where it's like 2x plus a and x squared minus
oh,
one and like,
there's a B
you
in
know,
there too usually. Yeah. Okay. Can we do
it's
one
like
of
fine.
those?
Sure. I will have to find one. But yeah, we can do that. Can we do part three first?
Yes.
All right. So for it to be differentiable, that means the derivative from the left has to be the same as the derivative from the right. So you can actually take the derivative of a piecewise function. You just take the derivative of each one, 2x minus 2x plus 4. And then you do the same thing. You say, well, is it the same? Are these the same?
Yes, they are.
Okay. All right, so they are differentiable. There it is differentiable at 1. And then you were asking about that kind of A and B problem.
Yeah. I'm also going to send you some pictures of implicit like relations
Okay.
of like some problems. Okay.
Um, all right, so here is one of those problems you asked for. So the thing that's often lost in these is that it has to be both continuous and differentiable.
Yeah.
So continuous is where you put the number in for X in the original.
Hmm.
That's part one. So could you do that for me and tell me what the two equations are?
Yeah. Okay. So 4a plus 10 and then negative 8 plus b.
And the problem with this is you got two equations and two unknowns, or one equation, one unknown, so that's bad. So you have to take a derivative here with respect to X. So that's 2ax and then 2x minus 6. And then you do the same thing. You put 2 in to both of those equations over here. So you end up
Okay.
getting 4a equals -2.
Mm, wait, 4a. I'm plugging 2 in, right?
Yes, always same value again.
So 4a equals -2. Okay.
So you can solve for a,
Negative 1/2.
okay, and then you put that in to find the value of b.
Okay. So,
Could
and
you
I
do
can,
that?
when I'm solving for b, I plug the 2 into the x, right?
We already did that. You're going back to this first equation.
Oh, -8 plus b? Or the 4a plus 10 equals. Okay.
Yes, that's the first one.
So b equals 20?
Try again. I got a different value. You got
Um,
4 times -1/2
oh, negative 1/2.
plus 10.
So 8, 16? Not 16?
Yes, yeah, b is 16.
Okay.
Okay, let me give you one to try now. Is that okay?
Yeah.
All right. Make sure this isn't too difficult. Uh, no, you can do this one. All right. These are not my problem. Just go out to the internet and find stuff, and I have, I always try to check before I put them up that they're not
Yeah.
super unreasonable. But same thing here on this one. And if you don't mind, I'm just gonna step away for 30 seconds. I'll be right back though.
Okay, no problem.
All right, I am back if you have any questions.
Okay. Okay, so I got to like so I plugged in 1 for both the equations to
So
start.
give me your two equations, or your left side and your right side.
Um 3x plus 4 equals 6x
Wait,
squared plus b
if
plus
you're putting it in for x, you should just get
oh,
numbers, no x's. There should be no x's in your first equation.
so 7
Okay, equals.
um 2 plus bc plus b plus c.
Okay, good. Now, next thing is to take a derivative of the top and the bottom, like the derivative of each.
So that's where I get 6x plus 4 and 6x squared plus x plus c.
The derivative of x is just the number in front of x, which is a
So
b.
b plus c. Okay. And I have to plug 1 into that.
Yes, it's another equation. So
So 10 for the first one.
okay,
Um, equals 6 plus bc plus b plus c.
so just 6 plus b.
What happens to the c?
We're
Oh,
plugging
it's
it
just a
over here in the,
full
yeah.
derivative. Okay.
Okay. So maybe the way I'm doing it's unclear, but like it's like it's two separate things. Now
Yeah.
you could get a system of equations like this one is not, but you could get that. And but here you can solve for B and then for C.
And then do I plug the b that I got into
Yes.
the regular, not the derivative, right?
The like ignore like you're just solving these two equations. You're done with the originals.
And then, okay. So 7 equals 5. Um, so I got 5 minus 5 thirds equals c, but I'm pretty sure I have to like,
Wait,
what's
what's the value of B?
5 thirds? 10 6.
Isn't it 10 equals 6 plus B over here on the right?
Yeah. Oh, so
So
it's 4.
yeah.
Oh, shoot. Okay.
I'm hearing like things that maybe you're tired and maybe like it's been a long day, but I like this is like something you'd be like, oh, this is easy. I've got the basic equations. There's no calculus. Um, 7 equals 2 plus 4 plus C.
Yeah.
The hard stuff is over. So the
One.
recipe, yeah, the recipe here is you put whatever the piecewise value is in back into both.
Okay.
And you get an equation. We did that in both these. Then you take the derivative of both and put the number back in. You get an equation, and that should be enough to solve for it.
Okay. Can we do one more?
If I can find one. These are hard to make up on the fly.
Yeah.
But I can try. All right, here we go. Wait, same as this one. This person borrowed from. That's funny. So I found one, but it was exactly like this one. They just borrowed from completely different instructors.
Yeah.
So if you ever wonder where your instructor gets their questions, they just go out to the internet and do that. So,
Yeah.
right. Try this one, please.
Okay. I got negative 2/3 for A
Okay. What about
and
for B?
1 2/3 for B.
So like maybe 5/3.
Yeah.
Okay. Um, so when I put one in, I get 1 cubed equals A, 1 - 2 squared plus B. So 1 = A plus B. Is that your first equation?
Yes.
All right, now for the derivative of each, okay, I'm gonna just move what you wrote down a little bit. The derivative, I'm gonna do that over here. What's the derivative of the top?
3x squared.
Good. This
And
bottom one's a little
then
bit more complicated. What did you get for that?
um 2a x minus 2. But I
Good.
think I'm forgetting. No, I'm
That's
not. I
that's
don't think
good.
I'm forgetting.
So now you
Okay.
put one in, so it's 3 times 1 squared. Notice when I substitute, I put in parentheses
Yeah.
2a 1 - 2. So we have 3 equals 2a, like that. Negative 2a, sorry.
Yeah.
Okay, so your answer is reciprocal. You got kind of that a is -3/2.
Wait. Negative 3/2. Why? Oh, because I'm
Uh,
dividing by 2.
yes,
Okay.
yes. All right, and then to find b, go back to this equation, -3/2 plus b. It will end up being, you're adding 3/2 to both sides, so b ends up being 5/2.
Okay. I think I get that.
Okay. All right. I know you sent over another picture, so I've got that uploaded. Where would you like us to go from here?
I think the implicit relations that I sent you, I have like 9 and 11 circled.
All right. So I'm only correcting you because you may say this in class and you'll just, it's not right. It's implicit derivatives. Relations are
Okay.
something else. And not really. So make sure you're using the word implicit derivative. Uh,
Okay.
so the ones you circled, are they like the ones that you know you need to do, or can I start with easier ones? Like what?
You could start with easier ones. Those are just the ones that I did for homework whenever we had those and I didn't know how to do them. So
All
like
right.
I asked.
Let's start with a basic thing here. All right. So the main thing with implicit derivatives is that x you treat the way you've always treated. The derivative of x squared is it's 2x.
Yeah.
The derivative of y squared is treat it like it's an x, so it's 2y, but whenever you have a y, you add in a dy dx whenever you're taking its derivative. Now, does your instructor use dy dx or y prime?
dy dx.
Okay. So now where this gets more complicated is over here on the right. This is a product rule.
Mm-hmm.
So which do you do? Keep the first or do you derivative of the first? Which do you do?
Derivative of the first times the
All right.
second plus.
Okay. So the derivative of x is 1 times y plus keep the first. The derivative of y is 1 dy dx. So
Okay.
look at this line one more time and just take a minute, 30 seconds here. Really make sure you understand where the dy dx are coming from. They come from the derivative of y.
Yeah. Yeah, I get that.
Okay. Now I'm just gonna slightly rewrite here. There's no more calculus. Calculus is over. Everything that's left from this point is algebra. It's just moving things around. So you get the dy dx is on the same side. So we're going to subtract 2x from both sides. All right.
Okay.
You're going to move the x dy dx to the other side. So the right side is y minus 2x. Do you see where those came from?
Yeah.
And then the left side is 2y dy dx minus x dy dx. You will move some number of terms left and right. Can't say how many, but you will. That's always the process. After you take the derivative, you collect the dy dx's on one side. Next, you factor out dy dx,
Okay.
and then you divide both sides by that. So there's your final answer. Your dy dx is y minus 2x over 2y minus x.
So, okay.
Is that okay so far?
Yes.
All right. Now we can do your problem. You're like number 9. Is that one you
Yeah.
want to do?
Yeah.
E to the xy equals tangent y. All right. What is the derivative of E?
Uh, the top, the derivative of the exponent
Forget
times the whole equation.
it's itself times the derivative of the inside function. Yeah. So now the the xy is product rule.
Yeah.
This is
Just like
product
we did
rules.
before.
Exactly. So what some students do is they remember this
Yeah.
because you tend to get a lot of xy's in these. I don't know if it's worth doing that, but you want to be comfortable with it. So you said derivative of the first times the second. Let's keep the first times the derivative of y, which is 1 dy dx equals. Derivative of tangent is what? What is derivative of tangent, if you recall?
Secant squared of x,
S-
or secant squared
Secant,
y.
secant squared y, but whenever you take a derivative with respect to y, you always have to add in a dy dx. All right. A little bit of cleanup here now, and then a lot of algebra to move some things around.
Yeah.
Okay, next thing is to actually distribute this e into both. So you get y e x y plus x e x y dy dx. All right, and
Okay.
then you can move some things around. Now, because normally we move left, but because there's only a dy dx here, I'm going to move this one to the right.
Okay.
And if this were like multiple choice, you might see a small difference in like the answers, but actually it's minus x e x y dy dx. And then you, whichever side it's on, you factor out the dy dx. And then you divide both sides. So you'll see I tend to move the thing we're solving for back to the left. Y e to the xy over secant squared y minus x e to the xy.
Yeah, that's what I got.
Great. All right, so you had another one circled here. What do we got here? These are so much fun. Not. All right, so this is x cubed y to the fourth, the power of 5 equals x minus y. You definitely want to apply this exponent rule to each of these first,
Okay.
rather than using power rule followed by chain rule.
Yeah.
The reason is a lot easier to do it this way. Um, always look for those algebraic simplifications. So uh, you derivative of the first is 15x to the 14th times y to the 20th plus x to the 15th, 20y to the 19th dy dx equals 1 minus dy dx.
Okay. 1 minus. Okay, yeah. And then I just move the dx over.
Yep. Uh, I guess I move the dy dx over and then this to the left. So it's x to the 15th. A lot of writing on these. And then you factor out the dy dx.
Plus dy dx equals 1 minus 14. Okay. Dy dx out. And then 20 x 15 y 19 equals. Wait. 1 minus. Plus 1. Okay, yeah.
If you got that down, I mean, I don't see why you not sure what it like. I think you would you'd be okay
Okay.
to I think you get this. I mean that the XY derivative is the big one that most students struggle with, which we're going way back up here. Well, anyway, that's the big one. Be able to take the derivative of x times y.
Yeah.
All right. What else on your review here? I think you said something about question 9, maybe R9,
Let me see.
which
Yeah.
I don't know if I have a picture of. All right. R9, Rover's tablecloth problem. Okay. These are related rates.
Mhm.
Does that sound familiar from class?
Yeah. We did a worksheet on them today, actually.
All right. Rover grabs the tablecloth and starts backing away from the table at 20 centimeters per second. Glass near the other end of the tablecloth um, moves toward the edge and finally falls off. Table is 80 centimeters high and Rover's mouth is 10 centimeters above the floor, and 200 centimeters of tablecloth separate. rover's mouth from the glass. At the instant the glass reaches the table's edge, was it going faster or slower than rover's 20 centimeters per second? Okay. So rover pulling this thing, I guess he's pulling it down. It's almost like a physics problem, not a calculus problem. But physics and calculus are actually really the same. So, um, what's the rate of this when it's table's 80 centimeters high? It's going faster or slower by how much? Right, I'm actually gonna check Chegg on this because I have no idea how to even begin
Okay.
this problem. And um, yeah, I actually have no idea where to begin on this. So why don't you ask your instructor? I mean, they're gonna have
Okay.
those solutions, and yeah, I don't want to go down this road of trying to guess
Yeah, no,
what it
that's
could be
totally
like.
normal.
Um,
Totally.
so you know we started a little late. Unless it's something really urgent, I can just owe you 3 minutes at some point down the road, if you really need it. But is it okay if we stop here for today?
Yeah, that's totally good.
All right. So I do